Dear students, now we are going to see one more naming reaction called Cannizzaro reaction. That is, here we have taken two aldehydes, that is, they are not having alpha hydrogen atom or they are the non-enolizable aldehydes. They undergo auto-redox reaction in the presence of concentrated NaOH or KOH, and we are getting two products. One is the primary alcohol, another one is salt of carboxylic acid. This primary alcohol is the reduced product and the salt of carboxylic acid is the oxidized product. We have known aldehyde, no? So that aldehyde on oxidation we are getting acid, that is carboxylic acid, and on reduction we are getting a primary alcohol. So that's why this aldehydes, no, that undergoes auto redox or self redox. We are getting primary alcohol and salt or carboxylic acid. Primary alcohol is the reduced product and carboxylic acid is the oxidized product, but here we are getting salt of carboxylic acid. That's why this reaction is called as disproportionation reaction, otherwise called dismutation reaction, because this is a self redox reaction. So what is that? It is the simultaneous oxidation reduction reaction. So now we are going to see examples for aldehydes that are not having alpha hydrogen atom. That is, the examples are formaldehyde, benzaldehyde, another one is glyoxal. Then one more is, so this is having 3 carbons, no, that is propionaldehyde, and second carbon is having 2 methyl, that's why it is called as 2,2-dimethyl propionaldehyde. So these are the simplest examples for aldehydes that are not having alpha hydrogen atom. Now we are going to see the reaction. So first, here we have taken 2 aldehydes, that is 2 benzaldehydes here we have taken. So this undergoes self-redox in the presence of concentrated alkali, that is concentrated NaOH or concentrated KOH. So one aldehyde, no, so that undergoes reduction, another one undergoes oxidation. So on reduction, the benzaldehyde would be reduced and we are getting a primary alcohol, that is benzyl alcohol. And this on oxidation we are getting a salt of carboxylic acid, that is the salt of benzoic acid, that is sodium benzoate, otherwise sodium salt of benzoic acid. So these two are the products obtained from Cannizzaro reaction. Now we'll see the second reaction. So here we have taken 2 molecules of formaldehyde. So that undergoes self-redox in the presence of concentrated alkali. One undergoes reduction, another one undergoes oxidation. On reduction, formaldehyde is reduced and we are getting a methyl alcohol. And this on oxidation, formaldehyde undergoes oxidation, we are getting a salt of formic acid, that is sodium salt of formic acid called sodium formate. Usually this reaction best proceeds with the aromatic aldehydes. So now we are going to see the mechanism for the first reaction. We have seen 2 reactions. Now we'll see the mechanism for the first reaction. Now we'll see the first reaction. So far it has 3 steps. We'll see the first step, that is nucleophilic attack by the hydroxyl ion on the carbonyl carbon. So first we have taken 1 molecule of benzaldehyde that is treated with a hydroxyl ion, and this reaction is a fast reaction. So by the addition of these two, the hydroxy ion, no, that is going to add the carbonyl carbon. So the negative charge becomes bond. That's why this bond becomes negative charge in order to satisfy the valency of carbon. So that's why we are getting the product as alkoxide ion, alkoxide or alkoxide ion, otherwise hydroxy alkoxide. So now we'll see the second step, that is the hydride ion transfer. Now we have taken that alkoxide, so that alkoxide is treated with another molecule of benzaldehyde. So by this addition, so this reaction, no, this is the slow reaction and that is the rate determining step. So now here what happens, the hydride, no, this is transferred from here to the carbonyl carbon of another aldehyde. So if that is moving, then what happens, to satisfy the valency of carbon, there may be formation of one double bond between carbon and oxygen. So here the negative charge becomes bond, and to satisfy the valency of this carbon, this bond becomes negative charge. That's why we are getting 2 products. One is benzoic acid, another one is benzoate ion. So this is benzoic acid, another one is benzoate ion. Now we'll see the third step, that is the acid base reaction, otherwise called as proton transfer. Now we have taken the two products obtained in step 2, that is benzoic acid plus benzoate ion. With this we have added one molecule of sodium ion. So by this addition, what happens, and the hydrogen present here, that is going to add this oxygen, and to satisfy the valency of that oxygen, the sodium present here is going to add that. That's why we are getting two products. One is sodium salt of benzoic acid, otherwise sodium benzoate. Another one is benzyl. This would be converted to benzyl alcohol. So these are the two products you obtain in the first reaction. Now here we have to know some points, that is the direct transfer of hydride ion from one molecule of aldehyde to the another, that is carried out by using the catalyst called D2O, that is deuterated water. If the aldehyde is having electron withdrawing group, the reactivity of aldehyde would be increased. If you are using acetaldehyde and ketones, that will not undergo this reaction because both are having alpha hydrogen atoms. So what is the main criteria? Nothing aldehyde, no, that should not have alpha hydrogen atom. So now we are going to see the mechanism for the second reaction, that is reaction between two formaldehydes. So here also it is having three steps. First step is the nucleophilic attack by the hydroxy ion on the carbonyl carbon. So first we have taken one molecule of formaldehyde. So that one is added with the hydroxyl ion. So this reaction is a fast reaction. That's why this hydroxyl ion is going to add the carbonyl carbon. That's why negative charge becomes bond. So bond becomes negative charge. So here we are getting alkoxide ion, otherwise called as hydroxy alkoxide. Now second step is hydride ion. So here now we have taken that alkoxy ion and that one is treated with another molecule of formaldehyde. This reaction is the slow reaction and that is the rate determining step. So here what happens, the proton present here, no, that is going to add the carbonyl carbon. That's why the negative charge becomes bond. So the bond becomes negative charge. So that's why we are getting two products. One is this one, that is formic acid, and another one is formate ion. So these are the two products obtained in step 2. And third one is acid base reaction, otherwise called as proton transfer. So here we have taken the products obtained from the second step, that is formic acid, another one is formate ion, and that one is added with sodium ion. So by this addition what happens, the hydrogen present here is going to add the oxygen. That's why to satisfy the valency of that oxygen, the sodium present here is going to add that. That's why we are getting two products. One is sodium salt of formic acid, otherwise sodium formate. Another one is this one, that is methyl alcohol. So that's all about Cannizzaro reaction. Thank you.